Welcome back, algebra students. In this video, I would like to discuss this one particular problem that deals with a radical equation. It's a slightly more complicated problem, so that's why I felt like I should dedicate one video solely to this problem. It's one of the more difficult equations that you might experience in this lesson. So I've got this equation, and what makes this difficult is the fact that I have this constant 2. If there was no constant 2, this would actually be a far simpler problem. But because of that constant 2, it makes it quite a bit more challenging. So what I will do first is add one of the radicals, or move one of the radicals rather, over to the other side. And I choose to add the square root of x plus 2 to both sides. So this will then produce a 2x plus 3, square root of that is equal to 2 plus square root of x plus 2. Now I will square both sides. Now when I square the right side, it's pretty familiar to what you did in other radical equations. But the right side is a little different. So let's do the left. The left side, the square root and the square do cancel out to leave you with 2x plus 3. On the right side, however, and I'm going to do this over to the right in red, what you have now is 2 plus square root of x minus 2, plus 2, times 2 plus square root of x plus 2. And you must distribute this out. So 2 times 2 is 4. 2 times square root of x plus 2 is 2 square roots of x plus 2. Then we have square root of x plus 2 times 2, so it's the same thing, 2 times square root of x plus 2. And then finally we have square root of x plus 2 times square root of x plus 2, which is really square root of x plus 2 squared, because whenever you take something times itself, you are squaring it. So let's simplify this a little bit. The square root and the squared cancel out of that last term. The two middle terms can be combined, so now you're left with 4 plus 4 square root of x plus 2, and then plus x plus 2. Now I do have like terms here. I've got the 4 and the 2 that can be combined, so I've got 6 plus 4 square root of x plus 2 plus x. Alright, so I'm going to rewrite this now over to my left and to substitute this into my equation here. I've got 6 plus 4 square root of x plus 2 plus x. Now what I will do is move the constant 6 and the variable x over to the left side because we have some like terms on the left side. So I'm going to subtract 6 and I'm going to subtract x. So now I have on the left side x minus 3 is equal to 4 times square root of x plus 2. From here, what I'm actually going to do is square both sides again. So I'm going to repeat the same process I started with. I'm going to square the left side, square the right side. On the left side, I'm going to distribute this all out, so it'll be x squared minus 6x plus 9 is equal to, now here I'm going to square the 4, which is 16, and square the square root of x plus 2. Well, that will just cancel out the square root, so it's just x plus 2. Now notice I wrote parentheses because remember this is 4 times the whole square root, whatever you're taking the square root of. So when you evaluate that square, you're actually going to keep the parentheses there because now it's 16 times that quantity. So I will distribute the 16. I have x squared minus 6x plus 9 is equal to 16x plus 32. Now I'm going to move everything over to the same side because I've got a quadratic and I need to solve that quadratic. So I'm going to subtract 16x and I'm going to subtract 32. So now I have x squared minus 22x minus 23 is equal to 0. And I must solve this, and I choose to solve it by factoring. So I have x and x. I have minus 23 and plus 1. And so my final answer here will be x is equal to 23 and x is equal to negative 1. Now I must check my solutions to make sure that they are in fact correct, or they do in fact work out. And what I find out is that negative 1 actually happens to be an extraneous solution, but 23 is a correct solution. So 23 happens to be the only solution to this equation.
And knowing the half of the battle,